Nvidia just committed to investing $100 billion in OpenAI, but not the way you'd think. They're not buying the company or taking equity. They are bankrolling the construction of the world's largest AI training infrastructure, 10 gigawatts of pure computing power. That's enough electricity to power New York City for an entire year, all dedicated to running AI models. Here's what's wild. This is the single largest infrastructure commitment any two companies have ever made together. Nvidia's deploying the first gigawatt by the end of 2026 on their new Vera Rubin platform, a GPU cluster so massive that a single data center could train multiple frontier AI models at the same time. For OpenAI, this is survival. They needed guaranteed chip supply. For Nvidia, it's dominance. They already control 80 to 90% of the AI chip market. Now they are financing their biggest customer, locking in decades of revenue, and cementing their position at the absolute center of AI development. But here's what most coverage gets wrong. This deal signals something massive about the future of AI competition. When the chip maker bankrolls the AI company, when supply and demand merge into a single entity, smaller competitors aren't just racing uphill. They are racing a mountain that's growing taller every quarter. To understand why Nvidia's willing to risk this much, you need to look at what happened in 2024 and 2025. OpenAI's problem wasn't building great models, it was keeping them running. ChatGPT, o1, their reasoning models, they're all compute monsters. A single training run for a frontier AI model now costs hundreds of millions of dollars and consumes weeks of GPU time. The bottleneck shifted. It wasn't algorithms anymore. It wasn't talent. It was literally the number of chips available. Nvidia already controlled 80 to 90% of the AI chip market. No competitor was even close. But even Nvidia couldn't manufacture chips fast enough. Customers were waiting years to get H100 and H200 GPUs. Think of it this way, imagine needing enough bricks to build 10 cities, but the brick factory can only make enough for one. That's where OpenAI was. They were scaling their models so fast that they'd burn through their chip supply in months. OpenAI's been raising billions in funding, but money alone wasn't solving the problem. You can't buy chips if they don't exist. So they needed a different approach. They needed Nvidia to guarantee supply, to commit to building infrastructure specifically for them. Nvidia faced their own pressure. They needed to show growth. Their biggest customer was fighting for scraps. Let's put this in perspective. 10 gigawatts sounds like a number, but it's actually a transformation of how AI development works. 1 gigawatt is enough to power about 1 million homes. 10 gigawatts is the continuous electrical footprint of a major city. That's not peak consumption, that's baseline, 24/7, running in perpetuity. For context, a large data center today uses about 50 to 100 megawatts. That's 1/20th of a gigawatt. OpenAI's existing infrastructure probably uses a few hundred megawatts spread across multiple facilities. Nvidia's promising to give them 100 times that capacity. They're building something that doesn't really have a precedent. The Vera Rubin platform is key. It's Nvidia's next-generation GPU cluster architecture, designed specifically for massive-scale training. Instead of connecting thousands of GPUs with traditional networking, Vera Rubin uses new interconnect technology to make 10,000 or more GPUs work as a single unified system. The first gigawatt deployment means roughly 10,000 to 12,000 of Nvidia's most advanced GPUs operating in lockstep. Here's the practical impact. OpenAI can now train models that would have taken a year to train in 6 months. Or they can run 10 different experiments in parallel where they used to run one. This isn't just faster AI development, it's a phase change. Every other AI company is playing checkers while OpenAI gets a chess engine. The electricity costs alone are staggering. At roughly 10 cents per kilowatt hour, 10 gigawatts costs about $876 million a year in power alone. So what does OpenAI actually do with 10 gigawatts of AI training compute? The answer's both exciting and terrifying. First, faster model releases. We've been waiting 6 to 12 months between GPT releases, o1 releases, major capability jumps. With this infrastructure, OpenAI could release new models every 2 to 3 months. Imagine GPT-5 in Q4 2026, GPT-6 by mid-2027. The pace of AI development just accelerated dramatically. Second, multimodal models on steroids. Right now, models that handle text, images, audio, and video together are still limited. With 10 gigawatts, OpenAI can train models that seamlessly integrate all these modalities at scale. A single model that's world-class at language, vision, audio synthesis, and reasoning all at once. Third, real-time AI services. Current AI systems process requests in batches. With massive compute, OpenAI can serve thousands of simultaneous users running complex AI tasks, real-time video understanding, live translation, instantaneous reasoning on massive documents. Fourth, AGI research. This is the uncomfortable one. With this much compute, OpenAI can now attempt training runs that explore whether we are approaching artificial general intelligence, systems that can reason across any domain the way humans do. That's not a small difference. That's the entire trajectory of the company shifting. But here's the twist nobody expected. More compute means more power for OpenAI, but it also means they need more power to keep training. To understand how massive this is, let's compare. Google's TPU, infrastructure for training Gemini, probably uses 2 to 5 gigawatts across their entire global footprint. Meta's AI training cluster uses similar scale. These are the world's richest tech companies, and they are measured in single-digit gigawatts of total infrastructure. OpenAI's getting 10 gigawatts in one location, potentially more coming later. They'll have more dedicated compute for training than Google and Meta combined. That's not hyperbole, that's the infrastructure gap widening into a chasm. Now compare it to the United States international competition. Chinese AI companies like Baidu and Alibaba are building aggressive AI infrastructure too, but they're working under export restrictions on advanced chips. They might have 5 to 10 gigawatts collectively by 2027. OpenAI's betting that Nvidia can deploy that entire amount in the United States within the next 2 years. For startups, forget it. A company like Anthropic or XI might operate on 100 to 500 megawatts of compute. That's 200 to 500 times smaller. They literally can't run the same experiments OpenAI can. They can't iterate as fast. They can't explore as many hypotheses. This is what happens when two companies decide to merge their interests. Nvidia gets to validate the Vera Rubin platform at scale. OpenAI gets to operate at a scale that makes competition nearly impossible. Everyone else watches from the cheap seats. And this is where things get complicated, because infrastructure concentration becomes a form of control. Here's what the financial headlines missed. This deal is fundamentally about power concentration. In previous eras, competition happened because multiple companies could access similar resources. Intel versus AMD, Microsoft versus Apple. They had different business models, different strategies, but they operated on similar technological terrain. AI compute is different. It's not software, it's not infinite. A gigawatt of compute is a physical resource. There's only so much electricity available. There's only so much fabrication capacity for the world's most advanced chips. When Nvidia commits $100 billion to OpenAI, they're not just buying loyalty, they're reducing how much chip supply is available to everyone else. Anthropic, XI, DeepSeek, Meta, Google, they're all fighting for the same finite supply of Nvidia GPUs. Every H200 that goes to OpenAI is one less H200 in the market. Every bit of Vera Rubin capacity that OpenAI locks in is capacity competitors can't use. The deal doesn't just give OpenAI an advantage. It deliberately starves competitors of resources. This raises a question that regulators are starting to ask quietly: is this anti-competitive? Not technically illegal, because Nvidia isn't blocking anyone from buying chips. But strategically, Nvidia's aligned themselves so completely with OpenAI that they'll prioritize OpenAI's growth over everyone else's. This is the uncomfortable truth nobody's addressing. AI dominance is now directly tied to infrastructure dominance. If you're building AI, working in tech, or just trying to understand where this industry's headed, here's what to monitor. First, watch Vera Rubin's actual performance numbers. Nvidia's claiming this is better than anything else. Let's see if they prove it. When OpenAI publishes papers about models trained on Vera Rubin, look at the training speeds. the efficiency gains. Real data will tell you whether this infrastructure is actually revolutionary or just expensive. Second, track the second and third gigawatt deployments. Nvidia's committed to the first gigawatt by the end of 2026. What about the remaining 9? If deployment slows down, if power infrastructure becomes a bottleneck, that tells you something about the realism of this timeline. If it accelerates, we're looking at a genuine phase change in AI development. Third, watch for competing partnerships. Will Google double down with their own internal TPU infrastructure? Will Meta and Amazon team up to build alternative compute? Will the United States accelerate their chip independence efforts? This deal is a signal that sparked competitors to react. The next 12 months will show whether this was an Nvidia win or the beginning of a compute arms race. Fourth, follow the electricity costs and power grid impacts. Running 10 gigawatts requires massive amounts of power. Where's it coming from? If it's fossil fuels, environmental groups will push back. If it's renewables, it'll force massive renewable expansion. So what's the bottom line? Nvidia and OpenAI just announced the largest single infrastructure commitment in tech history, $100 billion to build 10 gigawatts of AI compute. On the surface, it's about OpenAI getting the chips they need to stay ahead. Beneath that, it's about Nvidia consolidating their position as the irreplaceable center of AI development. But the real story is about concentration and control. AI development is becoming so expensive, so resource-intensive, that only massive companies with massive capital can compete. Startups can have brilliant ideas, but they can't run them. Research labs can innovate, but they can't scale. This deal solidifies a world where OpenAI and Nvidia set the pace and everyone else follows. Here's what this means for you. If you're in tech, you're watching the infrastructure game change beneath your feet. If you're concerned about AI's direction, you're seeing that direction get concentrated in fewer hands. If you're in policy or regulation, you're looking at the moment we should have asked hard questions and didn't. The infrastructure race isn't new, but it just became a concentration crisis. 10 gigawatts isn't just bigger than what came before, it's a different category entirely. It's the moment when AI development stopped being a race and started being a kingdom. Follow for daily AI news, because tomorrow's developments in AI won't wait.